Okay, so we're going to continue with the homework, and here these are fairly straightforward. So the secret is simplify and find the restrictions. So you got A and D in this one. So before we proceed, if we look, it's being multiplied, right? So we don't need to do anything for it. So we just need to look at the restrictions. The restrictions here is if x were to be 0 and multiply times 7, it would create a 0. So the only restriction here is that x cannot be 0. Then you move on and you start looking at things we can cancel, top and bottom. And you could spend a lot of time in figuring it out, but here's an easier way to look at it. Treat them all as isolated things when it's like this, and say, okay, well, I know that 7 can go into 21 3 times. So if I take 21 and divide it by 7, I'm left with 3. And if I take 7 and divide it by 7, I'm left with 1. So you're essentially dividing them both by the same thing. And then I can say, okay, well, I got an x here and 2 x's up here, so I'm just left with 1x. So I'm left with 3 times 2 and the x, which is 6x. And at the bottom, I'm left with nothing. I got rid of the x, I got rid of the 7, I got rid of everything. So the final answer is 6x, but x cannot be 0. And x cannot be 0 has nothing to do with the 6x. It has to do with the original denominator. Okay, and that's the thing to remember. You can have a 0 at the top of a fraction. You just can't have a 0 at the bottom. So that's a pretty simple one. It looks complicated, but I think the point of it is they're teaching you how to strike things out before you go too far. So we'll look at this one. So the restrictions have to do not with x, but with a and b. And since there's nothing going on at the bottom, we can see, well, we've got a dividing, don't we? So we've got to fix it. So we've got to switch the dividing to a multiplier, or just a dot, as I like to use instead of an x. And we got to flip these fractions. We're going to flip this fraction upside down if we're going to do it. That's the rule. Now we can look at the restrictions. So these are all multiplying each other. They're all multiplying each other. So anytime there's a 0 in one of them, it makes it the whole thing 0. So we can see instantly a cannot be 0 and b cannot be 0. Anything else is fine. The fact that it's b squared or a squared doesn't matter. 0 squared is still 0. Okay, so those are the only two restrictions. So you put them aside. And I'll get that right one day. And still don't. There we go. So you put them aside. And then you find the simplifying. And it's simply a matter of crossing out. So let's look at, we've got 2 b's here and 1 b here for a total of 3. Because when they multiply, and this is all multiplying out, they become b to the 3. And we have a b to the 3 out here. So b's are totally gone. B's are totally gone. And we can do the same with the a's down here. We got 1a here and 2 a's there for a total of a to the 3. And we have 2 a's up here and 2 a's up here for a total of a to the 4. Which means all my a's are going to be gone and all but 1 a is going to be gone up here. So we've gotten rid of all the b's, all the a's down here. And we're left with just the numbers. Well, fortunately the numbers are going to stick around. This 2 can go into itself once, and it can go into 14 7 times. So we're left with a 7. And remember, this a is gone. We're just left with a to the 1. So is this a. And now this 3 goes into itself 1 time, and it goes into the 9 3 times. So all we have down at the bottom is a 3. We don't have any a's, b's, or c's. And up top, we've gotten rid of the 3, we've gotten rid of the a's, the b's, we just got a 7 and 1 a. So that's all we got at the top. And the restrictions are as before. A can't be 0, and b cannot be 0. And that's the final answer. And it's really about practicing what can be eliminated. The reason we can keep striking these things off individually is because they're all multiplying each other. And when you have a long string of things, let's say I have 100 a squared, b cubed, c to the 9th, z to the, that's a bad 9, z to the 20th. And I have up here 200 a cubed, b squared, c to the 8th. And what was that? Z to the 20th? And z to the 21. I can cancel everything one by one. So 100 goes into 200 twice and leaves 1 down there. A to the 2 goes into a to the 3. It leaves just a to the 1 and gets rid of this one up here. So we just got a to the 1. there's 2 here and 3 here, so this b2 disappears, and it just comes b to the 1 up here. There's c to the 2 here, and c to the 9, was it 9? I think it was 9 down there. So we're left with just c to the 7 down here, and this one's gone. There's 20 z's here, and there's 21 z's here, so this z's gone, and we're left with just 1 z. So that's, you can just, as long as they're multiplying each other, and whenever they're side by side like that, it's saying multiplying, you can just eliminate them individually. Where you can't do that is if you suddenly had a plus at the bottom, for instance. And I'll just get rid of everything so you can see it. If I had 7a plus 3x plus 4b up here in a bracket, and down here I had 7a plus 3x plus 4 in a bracket, like that, yes, those just cross each other out. But let's say I had another plus z here. Suddenly they don't fraction out. They're not the same terms. So they cannot cancel out because suddenly something got added to that. If instead of adding it in that parentheses, I was multiplying by z, yes, these can still cancel out. I'm left with z down here and 1 up there. So you can see it's only multiplying that makes them free to be crossed out. And it's only matching terms. When it becomes a plus something, I must find an x plus 1 to cancel out. But beware, sometimes it's tricky. It might look like it's not an x plus 1. It might look like it's a minus 1 minus x up here. But if I take minus 1 out of that, it becomes a plus 1 plus x. And now x plus 1 or 1 plus x are the same. They can cancel out. All I'm left with is minus 1. So you got to watch for tricks. And that's what this practice is all about. Let's go on to the next one. This is question 5 now we're going on to. Okay, 5a. So they're multiplying, so it's not a big deal. And looking at it, I can see that there's no more simplifying to be done. Well, there is, but not factoring. So let's look at the restrictions. There's just this one. When will this bracket be 0? When x is minus 1. So x cannot be minus 1. That's the only restriction. Put it aside. Now let's look at commonalities. This 2 is multiplying this, and this is multiplying that. We can put it in brackets to make it clear, because it's a tied term with the minus. We should. So there's all multiplying going up here. There's an x plus 1 here and an x plus 1 there. They cancel out. There's a 2 up here. It can go into the 6 3 times. So we're left with 3 times 3 down here. And no numbers up there. We're left with just x minus 1 up there. So what we're left with is x minus 1 at the top. And underneath we're left with 3 times 3, which is 9. That's the final answer. And you can see you can simplify group terms. They were a bit tricky not putting this in parentheses originally, but because it's x minus 1 here, you might as well just put a parentheses around it. Let's look at D, see if that's any easier. By the way, anytime you still don't get it, let me know. So I'll just I might have forgotten to make the other one a bit bigger. So these can be slightly simplified. Up top, they cannot. We can see there's an m plus 4 and there's m plus 4 squared. Well, yeah, we can. These multiply to become m plus 4 to the 3. And we can just get rid of this one. And this 5, oh wait, I just saw the divider. So ignore everything I said. So there's a division here. So our first step is to multiply it. And then switch it around. Now I have a question. I'm going to look in the back of the book. There's a chance that I have to find the exclusion of that before I switch it around. But I don't think so. I think it's just what we switched around. There, that makes more sense. Now over here, up top, this one can be simplified. I've got a 7 here, and 14 can be divided by 7. So let's do it. Let's move it a bit to the side. When I take a 7 out of the first term, I'm just left with m. So the 7 comes out. And when I take a 7 out of the second term, 14 divided by 7 is a 2. So I'm left with 7 times this bracket. This one here cannot be simplified, but let's put it in a bracket because it's got a plus 1. We don't want to start accidentally getting rid of the 2 m's. This is multiplying, so that's fine. And believe it or not, we cannot do anything with the numbers. We got 21 up top and 5 down at the bottom. But here's 2 m plus 4's, and here's 1. So we get rid of this one, and we're left with 1 up top, which explains why it's not 3. And then we got an m plus 2 and an m plus 1, and that's where you might have been tempted to cancel out, but they cannot be canceled out. By the way, I think I forgot to do did I do the restrictions? Yeah, I forgot to do the restriction. So m cannot be equal to minus 4. And over here, how do we figure this out? We make it equal to 0. M plus 1 equals 0. There's the straggler. We got to get rid of it. So at 2m cannot be equal to minus 1. So then we got to divide by 2 to get rid of it. We're left with m is minus 1 divided by 2. That's what m cannot be right there. So those are the two things that m cannot be. And so what are we left with? We're left with 3 times 7 up top, so 21. We're left with m plus 4, because there was 1 left over. We're left with m plus 2, because there's nothing down below that's m plus 2. Down below, we're left with 2m plus 1 in brackets, and we're left with a 5, so we'll just put the 5 out front. So we got 21 over 5, and then these things. And I think that should be plus like that. Sorry about my writing. Not as hard as you think. You're just going to go step by step and just make sure you're doing the exclusions as you go. So for 6 now, your teacher gave you A, C, and D. Let's have a look. So the first one's this one. Pretty straightforward. So we got a multiplier here, so we can just put everything together. And I like to put my numbers out front. Since they're all multiplying, I can just put them anywhere I want. This is a law of math. When they're multiplying, as long as I keep the brackets, the same brackets. And down below, I can multiply as well. Now, is there any factoring to be done? Not really. They've pretty much factored it all. So I'm just going to put this a little closer to see it. And I'm just going to draw my line straight through so I can see it. So I can just look for exclusions first. X cannot be minus 2. X cannot be 3. And x cannot be minus 3. Positive 3 and minus 3. Those are the exclusions. Put them aside. Then you're going to look at what can be canceled out. So let's look at top. Do we have any x plus 1s at the bottom? No. Do we have any x minus 3s at the bottom? Yeah. We got 1 here, 1 there. They're gone. Do we have any x plus 2s? Yeah, we got 1 up top and 2 at the bottom. So this one's gone, and this one's just to the 1 now. Just to the 1. So that's it. Any left? No. So up top, we're left with 2 times x plus 1. And down below, we're left with x plus 2, just one of them's left, times x plus 3. And that's all we're left with. We don't want to expand it because we don't need to. It's simplified. The instructions were to simplify it. Done, and remember the restrictions. So I think here they're just getting you used to spotting it so that you can move on to this one. So this one multiplies, so we don't have to worry about it. But let's put brackets between all the things that are added together or subtracted together. And let's put all brackets beside these ones too. And you'll notice now, some of them have some numbers that can be factored out. But I'm going to just slide them all together to get rid of it to make it visually easier. Let's look at this first one. Well, no numbers can come out, but I can definitely turn that into something that's factorable. Down here, same thing. No numbers can come out, but it's something that's factorable. And I like to do my top first to give me hints at the bottom. Down here, none of these numbers have something in common. It looked like it at first with the 14 and the 8, but it's not. So it's a complicated factorial. And I might do the slide method for that one. We'll see if you can come up, but you can do the grouping method if you're not comfortable with it. So let's start with my top one. I'm just going to make a copy of it. You can just work with factors individually as you go. I'm looking for something that multiplies out to minus 2, because I got to take this term and multiply by that term, and adds up to minus 1. Well, 2 only has 2 terms, and in this case I know it's plus 2 and minus 1 because that works. Normally I just have x plus 2 and x minus 1, but I can't with this 2 in front. I'd have to group, but I'm going to do my shortcut method. I am indeed going to do x plus 2 and x minus 1. And instead, I'm going to take the beginning term, which is 2, and I'm going to divide each thing by 2. Okay? This is the slide method. So I didn't group it in common. I just divided each of the things by the number that was in front. This one simply becomes a 1. So one of my factors is indeed x plus 1. But this one cannot be made any simpler. So I take this 2 and I just put it in front of the x. So I've got 2x minus 1 is my other factor. If you multiply this out, you will indeed come to this top term. It works. So I can now replace my top term with this entire thing. Boom. That's my new top term. What about the next term? We're going to do the sliding method again. So you can do it if you want. Maybe your teacher will get mad if he sees you're not grouping, but whatever. So let's look at it. We've got to find a number that multiplies out to 6 and adds up to -5. It's going to be pretty simple. It's -3 and -2. Now normally I'd have to group it. I am not going to group it because I'm a crybaby. So I'm going to slide these numbers down so I remember them, and I'm just going to put what my factors were. -2 and -3. I'm just going to say x minus 2, x minus 3, just like that. And then I'm going to go back, and I'm going to close the brackets, rather. And then I'm going to go back, and I'm going to look at what number was in front of my complicated factorial. It was a 6, so I'm going to divide each number by 6, and I'm going to simplify the fraction. So this -3 over 6 simplifies. 3 can go into 3 one time and 6 twice, so it simplifies to -half. We're not done yet. We're not done yet. We're not allowed to have a half there. The other one simplifies to -1 over 3. If you don't know how to do that, practice your fractions. 1 over 3. We're not allowed to have a 2 here or a 3 here, so we simply put it in front of the x, and we're left with 2x minus 1 for the first one, and 3x minus 1 for the second. If you expand it out, you're going to discover it does indeed create this polynomial if I expand it out. The sliding method is just a shortcut, so I'm going to take this entire polynomial and I'm going to put it at my top. Ugh, this is exhausting, and that's unfortunately part of math. So this one down below is a simple factorial. We're left with x minus 3 and x plus 2. Again, with practice, you'll see it. So it's the only number that can add up to -1 and multiply to -6. So I'm going to slide this over, and I'm simply replacing this with that. Oh, did I screw that other one up? Yeah, I did. I'm going to slide this over, and I'm simply replacing this. I did it again. What's it doing? Okay, I'm not clicking it to get rid of it. Yeah, there we go. And I'm replacing this with that. Okay, let's get rid of that. It's confusing to see that. What about this one? Well, we're looking for a number that adds up or multiplies out to 40 and adds up to 14. Right away, since we're plus, I can see it's 4 and 10. I just saw it right away. 4 and 10. Now, normally I'd have to group it. And if you want to go to grouping, you go ahead and group it. You'd make this 4 and this one 10x. And then you put brackets around these two and brackets around these two. I'm not doing that. I'm tired of doing it. I know my factors are 4 and 10. So I'm going to just take x plus 4, and I know it's plus because of this. X plus 4, x plus 10, and then I'm going to bring the number that was in front, which is an 8, and I'm going to divide each of my numbers by 8. 10 divided by 8, and 4 divided by 8. 4 divided by 8 simplifies to 1 over 2. I'm not allowed to have a fraction, so I take that 2 and put it there. So I'm left with 2x plus 1. 2x plus 1. Woo, it works. I'm not allowed to have, this can simplify to 5 over 4. I'm not allowed to have a fraction, so I got to slide that 4 in front of the x, so I'm left with 4x plus 5. So let's replace that whole thing with 4x plus 5. You can see that speed-wise, 4x plus 5. You can see that speed, oh, I just hate that. Speed-wise, it's faster. 4x plus 5. Now, it's more confusing for you. Go to the grouping method if you want. Eventually, you're going to get tired of grouping and grouping and grouping. But there we go. I replace it. Now, find your restrictions. X can't be 3. X can't be -2. And look, this has to do with the half that I used to have. Because it's x cannot be equal to -1/2. Oh, interesting relationship. Remember how this used to be 5 over 4? Well, x cannot be equal to -5 over 4. There's a relationship there. You could have left it actually in fraction form, but no teacher likes it. Every teacher likes to see it like that. So we found all the restrictions, put them aside. That's one of the hardest ones to do. And now we're going to start canceling out. Do I have any 2x's minus 1s at the bottom? No, I have a 2x plus 1, and don't get confused. I cannot make those the same because if I take a minus out of one of them, the front term will become minus as well. So they'll never match. They'll never match. I do have 2 of them here, so I can make them squared and just get rid of one. Do I have any 3x minus 1s at the bottom? Any 3x minus 1s at the bottom? No. No. Boy, do none of them cancel out? Jeez. I'm going to check the answer at the back of the book. But it looks like none of these puppies cancel out. It looks like that's the simplest form there is. It looks like they should cancel out with this thing here. But no, it doesn't. That is definitely a minus. So I'm going to check the back of the book later and make sure that's correct. You're always got to look for things that can cancel out. Even if I were to expand this, it won't work because I'll get an x squared. So don't start thinking you got to expand it again. Once you reduce it to factor form, that's the simplest form there is. So if there's no cancellations, there are no cancellations. Interesting. Not sure about that one. I will check later and correct myself if I'm wrong, but I did get all the factors right. Now this is the last one your teacher wanted on your question 6. There's more homework that we can do. Your teacher assigned a lot of homework. And this one's divided. So right away, I'm going to switch this dividing sign to a multiplier, and I'm going to put this up top and this at the bottom. Okay? Like that. And actually, yeah. Now I'm going to put everything in brackets so that I don't get confused about what's what. These brackets are all multiplying each other. Now some things I can see that I can only take a number out of. Some things look like a difference of 2 squares, and some things look like a complicated factorial. And that one I can take a number out of. So it helps in your mind if you can identify it. Let's look at this one here. I said it's a difference of 2 squares. What are those 2 squares? Well, it's 3y plus 2, 3y minus 2. You need to learn how to spot those. 2, 2, 2. You need to learn how to spot those. Always look for when it's this simple and it's still a square. Look to see if that can be square rooted. Okay? What about this one? Well, they both have, notice all my other terms are y in the front, y in the front, y in the front. So I want my y over here. So I'm going to rearrange this to make it easy on me. I'm going to rearrange this to make it easy on me. And I'm going to put the minus 6y in the front. And I'm going to put the plus 18 afterwards. And now I can easily see what I got to take out. Got to take out the minus 6. So I can factor that out. I can put it right in front if I want. And I'm left with y minus 3. That's what happens when I factor it out. If you don't understand it, give me a call. Y minus 3. Boom. So I got the top, and there's probably some clues in there. This one, I can factor out a 4, and I'm left with y minus 3. That's because each of these terms, when divided by 4, become this. So I got a 4 down here, and y minus 3. I'm already seeing some stuff, right? This one here is a complicated factorial. To figure it out, I have to do 9 times 4. So I'm looking for a number that multiplies out to 36 and adds up to 12. And that happens to be 6 and 6. And since we're dealing with positives, it's positive, positive. So I would normally group them. But I'm lazy. I'm just going to say it's x plus 6. And then I'm going to take an x plus 6. We can just keep them the same if you want, but I know it's going to end up being squared. And then, oh, look at that. What a fool I was. That's a square root, and that's a square root. So right away I just know it's 3x plus 2 squared, and it's a perfect square. That's how we completed that. It's not y, it's not x, it's y. So boom, right away. This is a perfect square. 3y plus 2. That's because this is a square root, this is a square root, and 2 times this. When you multiply them and multiply by 2, you get that. Okay, and that's how that works. So right away over here, and that's a square by the way, I can replace that whole thing with 3y plus 2 squared. Now we're going to look at our restrictions. We can just get rid of this because it's ugly. We're going to just move this to the right, and we're just going to expand it. And we're going to look at our restrictions. Oh my goodness, what's my restrictions here? Well, you just make the whole thing equal to 0. You've got to get rid of the wedding crasher. That's 2. And then you got to divide by 3. So y cannot be equal to minus 2/3. That's that restriction. This one's easy. Y cannot be equal to 3. That's that restriction. Boom. Restrictions done. Put them aside. Let's do some simplification. Okay. All right. I see a 3y plus 2 up here and 2 of them down here. So I'll just replace this with 1 or just the bracket, like that. I see a y plus minus 3 down here and 1 up here, so those just go away. Minus 6 up top can be divided by 2 and become a minus 3. And plus 4 can be divided by 2 and become a 2. So those are simplified. And then 3y minus 2 cannot be simplified with 3y plus 2. They are different terms. And if I subtract a minus 1 out of here, this becomes minus 3y minus 2. Different terms, so I can't fix it. So I'm just left with minus 3 in brackets 3y minus 2 divided by 2 times 3y plus 2 in a bracket, and all my restrictions. And boy, that was fun. That was probably trying to make you spot a difference of 2 squares. So I'm just going to stop this one now and go on to the next one. Take a little break as soon as I can figure out